Awesome. So, good morning, everybody, and welcome to the first episode of today's podcast. I'm going to remind everybody that this is meant to be a podcast, so any pictures you see are supplementary and are lucky to be here in the first place. So, today we're going to talk about a topic that has been covered quite from many different angles and also in various levels of depth. But I think that this one is going to hit just a little bit closer to home. And obviously, I'm talking about voice activated saxophones. I'm kidding, no. But the situation that I'm talking about, we've all been here before. And this is when you whip out your smartphone or your desktop or whatever it is, and you activate your Google Assistant, Alexa, Cortana, or even Siri, and you ask it to play you some smooth jazz. But instead, you are now surrounded by 50 virtual stores, all giving you recommendations for shoe racks. And don't get me wrong, virtual, virtual, virtual driven voice-driven technology has come a really long way since the beginning. The cycle begins in 1950, where computers were room-sized and their knowledge of speech was very, very limited. So researchers at the then AT&T Bell Laboratories developed a system called Audrey, and this system recognized spoken digits. If we fast forward into the 1960s, IBM actually developed a system called Shoebox, not the shoebox, the shoebox. And this was a system that could comprehend 16 spoken words. Now, if you'd like to figure out what these 16 spoken words are, you can leave a message in the chat and I will make another video. I'm also kidding. Of the 16, out of the 10, 16 words, 10 of the 16 words were actually the numbers 0 up until 9. So we don't see a lot of growth between, if we compare with the 1950s, where it recognized spoken digits, which was as well 0 up until 9. But the extra words that it did contain was words like minus, plus, subtotal, total, false, and off as well. Now, fast forwarding into the 1980s, it brought a lot of excitement and a lot of different quirks. And here we enter Dragon Dictate, which was a system that required articulate pronunciation, as if you were speaking Shakespeare into the microphone. And it was quite promising, but occasionally it produced transcripts that seemed like secret messages. And if you're wondering this, yes, it's because they didn't name it after a person, like most of the other voice-driven technologies. And then in the 1990s, we see that voice-driven technology is actually finding its niche in companies like IBM, where they were releasing products that could understand over 1,000 words. So we see a lot of growth in between the 1950s all the way up until the 1990s. But in 2011, like a star from the sky or a knight in shining armor, Apple Siri debuts, completely transforming voice interaction. Now, not only did Siri understand us, but it also had a lot of humor and a lot of sass. And if we fast forward once again into the present, we can see that voice systems and voice assistants practically became household names, quite literally being able to dim your lights, make you coffee, and even suggest how to survive a zombie apocalypse, all with the exact same tone. And after going through all of this amazing technology and all of these really cool, innovative ideas, I wondered to myself, how does this work? And of course, like anybody else, born out of the year 2000, I whipped up my phone and I asked my Google Assistant. And at first, I thought I was trying to ask it how boys' colleges drive to work, which didn't really help me very much. And on the second attempt, I thought I was asking how voice remote ecology works. Now, this isn't exactly what I was looking for, but the very first article did highlight something quite important, and it spoke a lot about how voice-driven technology actually contributes to teaching people and educating people about how to live more eco-friendly. For example, Google's Assistant has features like Recycle Track that actually identifies different types of recycled products and how they can be recycled as well. It has another feature like Captain Earth, which educates kids on how to live green through interactive story-driven adventures. And even Alexa and Google's Assistant as home devices also have a lot of different features that actually help you save energy. But going back to the original point with how these systems actually work, I'd like us to take a very super serious approach at decoding how this actually goes down. So with step one, which is audio input and processing, this is essentially where it removes all of the echoes and all of the background noise in your audio to make your voice shine, so it can then move it on to the second step, which is feature extraction. Now, this is where it's sort of like a detective phase. It breaks down your voice into features. And these are features like pitch, features like tone, and features like frequency as well, and timing. And then it passes it on to the next step. Now, there are two different types of models that are used when we're looking at voice technology, or specifically voice recognition. And that's acoustic models and language models. Now, acoustic models is kind of where things get nerdy. And this is where the program consults with this dictionary of sound patterns, and it matches the features that it extracted previously to phonemes, which is the smallest unit of speech. And then it moves on to the language model. Now, the language model is like that friend that actually listens to what you're saying. It's not just listening to the individual words, but also interpreting the meaning within context of whatever it is that you're saying. So as it goes into the next step, which is decoding and interpretation, this is sort of the decision-making phase. So over here, it evaluates words and word combination, and it predicts the most probable sequence based off of what you're trying to say, based on all the previous steps that have happened up until this point. Then step 6, which is the second last step, is adaptation and learning. And we all know that AI is no stranger to growth and learning, and it learns from your interactions. It's like that friend who figures out what your coffee tastes, how you like your coffee without actually having to ask you. And then in step 7, which is the final step, it is the feedback step. And this is where we find out that your conversations with virtual assistants or voice recognition software are like gold mines, because this is where it actually takes time to understand your accents and your linguistic quirks. And it's like learning a new dictionary or a new dialect or a new language, but instead of using textbooks or different types of resources, it actually listens to the nuances and the different ways that you pronounce something relative to other people. Now, covering, I suppose, some of the biggest challenges, what I'm going to look at specifically, what I believe is the biggest challenge with voice recognition software. There's quite a lot of them, but data privacy is probably the biggest one. Privacy is the precious commodity that we have in our digital age. And the heart of the issue with voice recognition specifically is just simply how these devices have to operate, unfortunately. So to respond accurately, they actually have to listen to what we have to say and then process it as well, which means that they need to send our data to remote servers. And this data can include anything from mundane topics all the way up until very intimate, serious conversations. So as much as there are problems with voice recognition and voice technology, there's also a lot of solutions. Companies are taking a lot of different steps to addressing issues like this by using things like encrypting data transmissions when we do send audio, and also doing on-device processing. So things don't have to get sent to servers and can be just processed on your device. But I think that with like any technological advancement, there is a balance that needs to be struck in between convenience and also security. And yeah, that brings us to the end of this podcast. Thank you so much.